Okay, students, congratulations. We are on the very home stretch, and we've done a couple of tests and quizzes, and we're now gearing up for our very last quiz. And I just want to really encourage you, finish strong. The most important 2 points of any course are the first 2 weeks and the last 2 weeks. And if you can finish strong, if you can stay with it, keep doing your homework, don't let anything get in the way of it, you'll be really happy with yourself. And for many of you, this may be your last class you need to graduate and get your diploma. So, hey, this is a big deal. So finish strong, okay? All right, we're going to be talking about solid figures. So I want you to go ahead and freeze the screen and copy what you see on it, and I will talk to you about what's on the screen. All right, so recognizing some common solid figures. And first of all, there's a definition that you should have copied down already. It's solid figures take up space and they have volume. So if I want you to think of a pop can, it takes up space in your hand. You can touch it, you can hold it. Your bed is a solid figure. In a sense, a door is because it has some depth to it. And these are some common solid figures. We've got the first one here called the cube. Okay. And this figure is, you see think of like an ice cube or something that's a square object and it's just perfectly square. That's what we're going to be calling a cube, something that's just perfectly square and all of its dimensions are the same length, width, and the depth of it. Okay. Then you've got a rectangular solid here, and this figure that's a rectangular solid, it's a rectangle, but it's also solid. And some people build platforms, stages are often rectangular solids. A cylinder, you've got your pop can here. Okay. You might have seen giant containers that they use to store water, and those can sometimes be cylinder in shape. And then you've got something called the cone here at the bottom. And a cone, if you could think of like an ice cream cone, might be one way to think of it, or a party hat. So people wear at parties, birthday parties, this hat. Okay. So what I want you to do is this should be pretty easy homework. I want you to stop the video and do problems 1 through 12 on page 128 of your textbook. And those should be really easy. You're just identifying shapes. Okay. All right. I'm going to move straight on to the next slide. And I want you to freeze the screen and copy this and then come back. So we've got something called volume now. You remember in our other lessons, we had something called area, which was a surface of a flat surface like the floor of a room. Okay. And but now with volume, we've got basically, if you want to think about it, think about a swimming pool. How much volume of water is in that pool? Okay. And so there's two ways to measure this. There's the measure, it's the space. Okay, I'm going to underline this at the top, taken up by an object. Okay, like your pop can, like your bed. Okay, like a rock. Or it can be the space enclosed by it. Okay. And so if you look at my figure at the bottom that's got the 5 by 5 by 5, all the space inside of it, enclosed by it. So like, for instance, think about the room that you're sitting in right now. It's got 4 walls around it. Okay. It's got a ceiling and a roof, and all the space within it is the space enclosed by it. So that's what that means. Okay. And so the first formula I'm going to give you is for the square. Okay. So if you're taking notes, might want to simplify this. This is just a formula. Okay. Here's our formula here for the volume of a square. And that formula is right here. It's LWH, which stands for, as I've written below, the length of it times the width of it times the height. Or another way to think of that is, since it's a square, all the sides are the same. I'm going to circle this on the far left. It's L, whatever side, the length of one side, cubed, which means times, 3 times itself, like 3 times 3 times 3. Okay. So if I look at the example I have on the screen here, I've got a cube, like a Rubik's cube. And it's got a length of 5 feet wide. It's got a height of 5 feet wide, and it's got a depth of 5 feet wide. If you think of the this is kind of the depth that I'm drawing an arrow towards the back of it, from the front to the back. So 5 times 5 times 5 would be, if I was going to do the formula for this the volume of this particular cube, it'd be 5 to the third. Okay, which is 5 times 5 times 5. Okay. And that gives you the volume of a cube. Now, keep in mind that a cube, if you remember, as a shape from our last page, is something that has the same length, width, and height, just like this one on the screen here. Okay. So let me show you a sample problem on my next slide here. And that'll kind of help us to kind of get into trying to solve for the volume of things. All right, let's take a look at this one, our sample problems. Go ahead and freeze the screen, copy it down, and I'll jump right into this, okay? All right, example question. What's the volume of the cube pictured to the right? Typical kind of problem that you would have, okay? And I want you to visualize that it says over here, it says it's 4 feet by 4 feet by 4 feet, okay? Now, I want to remind you that the way I've been training you in this class is to rewrite the formula for what you're trying to solve on your paper, just like I've done over here in the top right here of the screen here, okay? Just takes you, less than 5 seconds. The volume formula equals S to the third, okay? The side to the third, okay? So the volume, if I plugged it in below, would be 4 to the third, which is 4 times 4 times 4, which is 64. And then you'll notice how I wrote this out here, square feet, okay? And so what that means is, if this was, I'm just going to draw this picture, and I'm not the best artist in the country, just second best. No, I'm just kidding. But I'm drawing my diagram here, okay? And this is, let's say this is a square foot, that it's 1 foot by 1 foot by 1 foot, okay? 1 by 1 by 1 feet deep, okay? Well, if that was a perfect square, okay, you can imagine that there are 64 of these square feet inside of my cube here. My cube is 4 feet by 4 feet by 4 feet, which is a lot, by the way. Okay, so I want you to do the problems on page 132. Just do the odds before moving on to the next slide. All right. Go ahead and freeze the screen, copy this on the screen, and when you've got it all copied down, you'll be ready to listen and just kind of take a few more notes. So rectangular solids. So we've moved on from cubes, which have the same sides and depth to them, so to a rectangle, okay? And here's my formula, okay? You should write this in your notes, is LWH, which stands for volume equals the length times the width times the height of that rectangular solid, okay? So I've got a sample question down here in purple. Sample question, what's the, THE, what is the volume of a rectangular solid to the right? Okay, and so there's my rectangular solid here. And it's got a height of 4 feet, it's got a length of 3 feet, and it's got a depth of 2 feet, okay? So again, please write out the formula. Volume, V equals LWH, okay? Plug in your numbers. V equals 4 times 3 times 2. V equals 24 square feet. Okay, so that's all you're going to do. You're going to copy down the formula next to each problem. You're going to go to the next step and do it just like you've seen me do right here. Okay, if you do this on every problem and take your time and go slowly, you'll actually go more quickly because you'll be getting the right answer and you'll be memorizing the right steps. All right, so do the problems 2, 4, 6, 8, and 10. I decided to give you the evens this time on page 133 and 134. And in the meantime, I'm going to push on to the next slide here. All right, you can freeze the screen. So now we're talking about cylinders. Think pop cans, okay? Think of your Red Bull or your whatever you happen to drink, okay? And there's a formula. Here's our magic formula for this, okay? And it's starting to look kind of like Greek to us here, and that's because we actually do have a little Greek once again in it. The volume for a cylinder, now it's like this shape here, this cylinder here, this pop can here, okay, is pi. Okay, you remember we introduced this concept of pi. That's our Greek symbol. Okay, times r, which is the radius squared, times the height, the h. Okay. Now, some of you right now might be getting nervous and going, "Oh man, teacher, how am I going to even remember this? It's really confusing." Good news, you won't have to remember it all. You'll have like a cheat sheet where you'll have these formulas written out. There's a page coming up in my next lesson. I'll show you where all these formulas are on the same page. You can have that page open on the test and on your homework. It's just knowing what these symbols and things mean. Okay. So I'm just going to review them again. Pi underneath is 3.14. Okay. And it's easier to do that on a calculator than to do 22 over 7. So that's pi. The r equals the radius. Okay. And if you remember from our lessons before, the radius is the distance halfway across. So if you look at my example of my cylinder here, it shows that R at the top there, and that's the distance halfway across the cylinder. Okay. And just in case you were wondering, the distance all the way across was called the diameter. Okay. And then this H here, the H, which I'm now writing underneath here, that stands for the height. Okay. That's how tall it is. And and so it's designated by the letter H. And you'll see that again. I'll just draw my arrow here. There's my H, my height of my cylinder. Okay. So that's what those mean. Let's take a look at our sample question. Find the volume. Notice we're saying volume now. That's our new word of the cylinder to the right. So I've got this pop can that is, we'll say that this M stands for meters. Okay. I'm just going to write this. It's meters. Okay. Um, so it's 10 meters tall. You can see that. And it's got a radius of 4 meters. The diameter would have been 8, but it has a radius of 4. Step 1, it's asking you for the volume, and it's asking for the volume of a cylinder, which I'm highlighting here with my highlighter. Okay. So here's again what I want you to do. Write out the formula, just like you see me doing here, putting my box around. Volume of a cylinder, V equals pi r squared H. Okay. And then start plugging your numbers in right underneath it. V equals 3.14. That's pi times, all right, what is our radius? 4. So 4 squared times, what's our height? 10. There it is. It's all written out there. Okay. And then if you punch those numbers into your calculator, and just want to remind you, 4 squared means 4 times 4. So really, this is 3.14 times 16, which is 4 times 4 times 10. Okay. And that should get you 502.4 cubic meters. You'll notice I wrote CU for cubic. Okay. And then M for meters. Okay. All right. For the cylinders, for your pop cans, you're going to, or a swimming pool of some shape, a round one. I want you to do problems 1, 2, and 3 on page 135 of your textbook. And let's move on. Okay. I'm going to talk about cones. Okay. And let me see if I can do something here. I'm going to grab something and see if this helps to pull this over a little bit. Yeah, that's helping somewhat. Okay. Um, let's see here. For some reason, I'm off the screen here, which is really odd. So tell you what, I'm going to grab the screen and pull it back here, and we'll just kind of work with it. So the volume of cones, the formula is V equals, please write this down, 1/3. You'll notice this is 1/3. I want to really emphasize that's not a half now. It's 1/3 times pi times the radius squared times h. Okay. And so again, if I grab my screen and kind of pull this over here, you can look at this upper right-hand corner picture. Volume of a cone equals 1/3 times pi r squared h. Okay. And again, we're just going to plug those numbers in, but let's take a look at my sample question. What's the volume of the cone to the right? So we've got a cone here, and I'm going to pull everything way over here like this now. Okay. All right. That should be helpful. So I've got a cone here that has a radius of 3 inches, and it's got a height of 9 inches. Okay. Again, I've written down my formula. V of a cone is 1/3. Don't confuse that with 1/2. That's critical. Okay. Now it's 1/3 times pi times the r squared, and the r stands for radius, times the h, which is the height. Okay. Plug those numbers in, and you will see here to the right that I've got, if I grab my pen here, I've got the V equals 1/3 times 3.14. That's my pi times 3 squared. Where did I get the 3? Because it's the radius of 3 here at the bottom of that cone. Times 9. Where did the 9 come from? It's the height. That's the H. Okay. If you plug those numbers into your calculator, you should get 83.92 square inches, would be the way we would reference that, okay, as square inches. Okay. I want you to complete your homework in pages, do problems 1 through 3 on page 136 of your textbook. And if you have any questions at all, if you run into any problems with this, please be sure and shoot me an answer. And just as a heads up, our next lesson is going to be a review of all these shapes and putting them into story problems, and a review for the final test, which is very exciting. And then you will be all finished.